Good morning and Sairam. In previous video we have done Newton's first law of motion, inertia and momentum. So before going to start our today's lecture, what we will do? We will do a quick revision what we have learnt in our previous video. Let us start with the first law of motion. What is the first law of motion? First law of motion stated that if a body is at rest, will remain at rest, or if a body is in a motion, it will continue with a motion until and unless you will not apply any external force on it. Clear? What it means? It means if a body is at rest. For example, this box will remain at rest until and unless you will not apply any external force on it. If you will apply external force from this side or this side or this side or that side, it will start shifting. That means it will come in a motion. But if you will not apply any force on it, it will remain as it. Clear? So that means if you want a rest body to move, what you have to do? You have to apply an external force in it. What you have to do? You have to apply external force on it. Similarly, if a body is in a motion, it will remain in a uniform motion until and unless you will not apply external force on it. Example, if a car is moving, it will move with a uniform speed unless and until you will not apply brake to stop it. Clear? This means for changing the state of motion, what you have to do? You have to apply external force on object. What you have to do? You have to apply external force on object. So this is the first Newton law of motion. This law is based on inertia. This law is based on inertia. So, what do you mean by inertia? Inertia is tendency of any object to remain at the same state of motion. What do you mean by inertia? Inertia is a tendency to remain at the same state of motion. For example, a bus. Take, if you will sit in a bus and a driver just suddenly start a bus, you feel jerk. Why you feel jerk? Because your body try to remain at the rest, but suddenly a bus starts, so you feel a jerk. So basically your inertia is tendency to remain at the same state of motion. Now the next topic is momentum. Basically your momentum, your second law of motion is based on momentum. So what is momentum? Momentum is indicated by indicated by small p, and momentum is a product of mass into velocity. Clear? Momentum is a product of mass into velocity. So you can define momentum. Momentum is a product of mass and velocity, and its mathematical expression is small p is equal to m into v. Clear? So now topics to be covered in this video are Newton's second law of motion and numerical based on Newton's second law of motion. What are we going to cover? We are going to cover Newton's second law of motion and numerical based on Newton's second law of motion. So let us start. So here the Newton's second law of motion. Basically your Newton's second law based on momentum. This thing I told you earlier also. Second law based on momentum and first law based on inertia. Clear? So what is the second law of motion? Basically your second law of motion is rate of change of momentum of a body is directly proportional to the applied force. That means your momentum is directly proportional to the applied force. That means your P is directly proportional to applied force, and take place in the direction in which force acts. Clear? So here the mathematical expression for Newton's second law is force is equal to change in momentum upon time taken. What is the mathematical expression for second law of motion? Change in momentum upon time taken. Clear? And I am reading once more. The rate of change of momentum of a body is directly proportional to the applied force and take place in the direction in which force acts. That means if you are applying force from this side, so this body will shift only this side. It will not shift this side. That means from in which direction you are applying force, only body will shift towards that direction only. Clear? And your force momentum is directly proportional to force applied. And what is the mathematical expression for second Newton's law? F is equal to change in momentum upon time taken. Now we will do derivation of this. How you will come this, okay? Now I told you, listen there. According to Newton's second law of motion, the rate of change in momentum of a body is directly proportional to the applied force. I told you this thing earlier. And take place in the direction in which the force acts. So your F is equal to change in momentum upon time taken. Clear? F is directly proportional to, this is the sign of directly proportional. What do you mean by directly proportional? Directly proportional means if one thing is increasing, so second thing automatically increase, and if one thing is decreasing, then second thing will automatically decrease. They are correlate to each other. Clear? So your F is directly proportional to change in momentum upon time taken. Clear now? Now consider a body of mass m having initial velocity initial velocity u. So what is the momentum? Momentum is mass into velocity. Clear? Your momentum is mass into velocity. So here your mass is m and your velocity is u. So your initial velocity is mu. Clear? Your initial velocity is mu. So it is written over here. Initial velocity of the body will mu. Similarly, if you applied an external force on it, when you will apply external force on it, that means its velocity will change. Now its velocity will become u to v. Mass will remain same, small m. Now its velocity will change and it becomes v. So your final momentum is P is equal to mass into velocity. Here mass is small m and velocity is small v. So it is mv. Clear? Now the change in momentum of this body is, now change final velocity minus initial velocity. Clear? So here you will write that F is directly proportional to mv minus mu upon time t. Mu will take common, v minus u upon t. And we all know that what is the mathematical expression for acceleration? Acceleration is equal to v minus u upon t. So instead of v minus u upon t, you can write F is directly proportional to m into a. That v minus u upon t, this is replaced by a. Why? Because we know that acceleration is equal to final velocity minus initial velocity upon time. So instead of v minus u upon t, we can write a. Now we want to remove this proportionality sign. See, if you want to remove any proportionality sign, that means you have to put any constant, and here we will put F is equal to K into M into A, and the value of this K is 1. So your F is equal to M into A. Clear? So your F is equal to M into A. Clear? See, with this we can say that force is directly proportional to change in momentum. If momentum will increase, force will increase. If momentum will decrease, your force will decrease. And force is inversely proportional to time taken. If time increase, force decreases. And if your time increase, force decreases. And if your time decreases, your force increases. Inversely में आपका उल्टा होता है, and proportionality में it will go same on a same side. Clear? I think this numerical is clear to you. Your F is directly proportional to change in momentum upon time taken. What you have to do, you have to take a body having mass m and velocity v and time t. So your initial momentum will be mu and your final momentum will be mv. Clear? Now, the acceleration produced in a body is directly proportional to the force acting on it. What expression we will get? We have got F is equal to M into A. Clear? And if we will remove that is equal to sign, what will come? Proportionality sign will come M into A. That means if your force increases, your mass is also increased. That means if you have large mass, you have to apply more force. If you have large mass, that means you have to apply more force. And if you're having a less mass, you have to apply a low force. Clear? So here, and with the same acceleration, if your force increases, acceleration is also increases. The acceleration produced in a body is directly proportional to the force acting on it and inversely proportional to the mass of the body. Clear? Now, if the mass of the body is doubled, see, your acceleration is inversely proportional to the mass. Clear? If your acceleration doubled, then your mass will be halved. And if your mass is halved, then your acceleration will double. You can say simultaneously. Clear? Because it is inversely proportional. If one will increase, so second will decrease. Clear? Now, since acceleration produced is inversely proportional to the mass of the body, it means it will be easier to move light bodies. Clear? And it is difficult to move a heavy body. Clear? I am reading once more. Listen carefully. The acceleration produced in a body is directly proportional to the force acting on it and inversely proportional to the mass of the body. Therefore, if the mass of a body is doubled, its acceleration will be halved. If the mass is halved, then acceleration will get doubled. Since the acceleration produced is inversely proportional to the mass of the body, it means that it will be easier to move light bodies than heavy bodies. The SI unit of force is Newton and it is denoted by capital N. What is the SI unit of force? It is Newton and it is denoted by capital N. 1 Newton is a force which when acting on a body of a mass 1 kg produces an acceleration of 1 meter per second square. If you are applying 1 Newton force on a body of having what? 1 kg mass. So, how much acceleration will produce? Acceleration will produce 1 meter per second. And if minus sign will come with a force, that indicates that force acting on the opposite side. Clear? I am reading the slides one more. Listen carefully. The SI unit of force is Newton. It is denoted by capital N. 1 Newton is a force which when acting on a body of a mass 1 kg produces an acceleration of 1 meter per second square. If minus sign comes with a force, it will indicate that the force is acting in a direction opposite to that in which the body is moving. Clear? Now we will do application of Newton's second law. What are the application of Newton's second law? Number 1, catching a cricket ball. Number 1, catching a cricket ball. Number 2, the case of high jumper. The case of high jumper. Number 3, the use of seat belts in a car. Number 3, the use of seat belts in a car. See, now I will explain one by one. If a ball comes with a force, clear, and a cricketer want to catch it, if he will keep their hands behind, then it will prevent from the injury. Why? Because when the balls come, the momentum is high, clear, and if you will put your hand behind, it will take time to come back, and in that case your momentum of that ball will become low, and you will prevent your hand from injury. If you want to catch early, your hand will get injured. Clear? That's why the cricketer always catch with this position, not with this position. Clear? So, and the second case is a case of high jumper. If a high jumper lands in a soft cushion surface, it will take more time to stop it. That means it will take more time to come momentum 0. So, and he will not get hurt. That's why? Because it will take time to stop. It will not stop suddenly. If the momentum will become 0 slowly, so because of that person will get hurt. That person will not get hurt. Clear? And the use of seat belts in a car. If a car in an accident, a car's momentum becomes 0 suddenly. Okay, if a car get accident, its momentum becomes 0 suddenly. So your seat belts will take time to fall that person. Clear? So if it will take time, so that person will get hurt less as compared to if you will not put a seat cars. So these are the application of Newton's second law of motion. First application is very important. The question will come from this application. Clear? Now we will do some numerical based on Newton's second law of motion. Let us start. So, what force would be needed to produce an acceleration of 4 meters per second in a ball of mass 6 kg? Very easy. Acceleration is given to you. It is 4 meters per second square. And mass is given to you. This is 6 kg. So, you know what you have to find? You have to find force. And you know that force is equal to m into A. So 6 into 4, that is 24 Newton. Clear? Acceleration is given to you, mass is given to you. What you have to find? You have to find force. So force is equal to m into A. Clear? Put the value of m and A and just got the answer. What is the SI unit of force? It is Newton. Let us start the second numerical. What is the acceleration produced by a force of 12 newtons of an object mass 3 kg? It is very easy. You have to find acceleration. Clear? Force is given to you, it is 12 newton, and mass is given to you, it is 3 kg. Clear? F is equal to m into A. So your A is equal to F upon m. What is the value of F? It is 12 upon 3. 3 ones are 3, 3 4s are 12. So your answer is 4 meters per second square. Clear? Force is given to you, mass is given to you. You all know that F is equal to m into A. So your A is equal to F upon m. Just put the value and get the answer. Now calculate the force required to impart to a car a velocity of 30 meter per second in 10 seconds starting from the rest, and the mass of the car is 1500 kg. Mass is given to you. Clear? 10 seconds velocity is 30 meter per second. That means initially that car is in at rest. So your m is equal to 1500 kg. Your u is equal to 0, v is equal to 30 meter per second, and t is equal to 10 second. From the first equation we know that v is equal to u plus at. Just put the 30, 0 plus a into 10. 10a is equal to 30, a is equal to 3 meter per second. Now you got the value of a. Clear? Now f is equal to m into a. Put the value and get the answer. Clear? See, in this you have to find the acceleration. Initial and final velocity is given to you and time is given to you. If initial and final velocity given to you and time is given to you, it is easy to find acceleration. What is the formula of acceleration? V minus u upon t. And with the first equation you will find v is equal to u plus at. Clear? Sorry, with the first equation you have to find. Clear? Now a truck starts from a rest and rolls down a hill when constant acceleration. It travels a distance of 400 meters in 20 seconds. Find the acceleration and find the force acting on it if the mass is 7 metric tons. First, what we have to find? You have to find what? Acceleration. Here distance is given to you, initial velocity is given to you, time is given to you. What you have to do? You have to find acceleration. With which equation? With the second equation. And what is the second equation? S is equal to ut plus half at square. Ut plus half at square. Just put the value. Distance traveled is equal to 400 meter. U is equal to 0. T is equal to 20 seconds. You have to find A. 400. Just put the value, but you will get acceleration is equal to 2 meter per second. And you know that F is equal to m into A, and 1 metric is equal to 1000. So 7 metric is equal to 7 into 1000 kg. So what you will get? 7000 kg. So here mass will be 7000 and acceleration is 2 meters. It is 14,000 Newton. Clear? Shall we move to next one? Here a force of 5 Newton gives a mass of m1, an acceleration of 8 meter per second, and a mass m2 and acceleration of 24 meter per second. What acceleration would it give if mass tied together? So in the first you will find what? What is the question? What you have to if the both masses are tied together. Clear? Force is 5 Newton and m is equal to m1. Clear? So first you will find m1. Acceleration is given to you, it is 8. F is given to you 5. Just put the value. What you will get? Your mass 1 will be 0.625. Similarly, you have to find mass of second body. F is given to you and acceleration is given to you. Just put the value and get the value of m2. After that, just add it. You will get the total mass and just put F is equal to m into A. Then you will get the answer. Clear? Because force is same, and if they are tied together, that means your m1 plus m2. Clear this thing? Now the last numerical. What would require a greater force accelerating 10 gram mass at 5 meter per second for our 20 gram mass at 2 meter per second? In first case you will find what? Force, and in second case you will find force. F is equal to m into a. Here your m is 10 gram. Here your m is equal to 10 gram and acceleration is 5. So 10 into 5, and it is your gram. First you will convert this gram into kg. So 10 upon 100, 1000 sorry, into 5. So it will come 0.05. Similarly here it will come 0.04. So which one required more? This first one will require greater force. I think with this everything is clear to you. If you're having any doubt, you can message me. Thank you and have a nice day.